Hello everyone, welcome to Mrs. Sun's math class. So today we study the topic 2, Indices and Surds, lesson 3a, review of index laws. So you can check the learning intention, and basically today we will review all the index laws we studied in our year 9. So you can have a look, do we have the laws here and also the zero index here. So if you can understand all of this, that means you should be fine for today's learning. And they have a lot of questions. You can do exercise from our Cambridge textbook. And you can see something from our Hazy. So now we can have a look. So from the Hazy, they have some keynotes like this. And before we start, we have to talking about what is the indexes. Okay. So now guys, when we're talking about indices, that always means we can do a exponential or we have the same base and we have the times and not only once, so maybe twice or 3 times or 4 times like that. So at the beginning when we study the index or indices, first you have to know you have a base A, and for example, to the power of m, and for example, I have 2 to the power of 3, so that means it's 2 cube. So it means 3 lots of 2 times each other. So guys, I have students always saying 2 to the power of 3, that's equal 6, miss, because that's 2 times 3. No, that is not. Power is like 3 lots of 2 times each other. If you want to do 2 times 3, that is just multiplication. You have to show as this way, okay? Then that will be equal 6. On top, you have 2 times 2, 4, double again, so that's it's 8. 2 to the cube equal to 8. 2 times 3 will be equal to 6. And here, these two, we call them base. So this A, same thing, we call them base. And this m, we can call them exponent or indices. Okay, so index, and if they are more than 1, so indices. So 2 to the power of 3, that means 3 lots of 2 times each other. So a to the power of m, it also means they have m of lots of a times each other. So it's m lots of a times each other. So now we can have a look. For these indices, we have a lot of laws we can use that. For example, we have a look at the first law here. So first law is on beside. So okay, guys, you can see here, there also some introduction about the base is A, and X is your indices or power or exponent. So depends on the textbook. Okay, some textbook also say the whole thing will be the power. Okay, but when you see these 3 words, you all know we're talking about the indices kind of question. Now we have a look. They introduce all these laws. We can use the hazy one or we can use this textbook. So now we have a look. So we use the hazy one. So first I talking about the first law. So a to the power of m times a to the power of n, they will equal a to the power m plus n. Now I give you example. So 2 to the power of 3 times 2 to the power of 4. So that will be equal 2 times 2 times 2 because it's cube. 2 cube means 3 lots of 2 times each other. And then 2 to the power of 4, so 4 lots of 2 times each other. So then in the middle, there are times symbol. So that means you time each other. And then we just count how many 2, because we have same base 2, 2, 2, continue. So I have 7 2s. So I can write down 2 to the power 7. So this one is exactly equal. That is 7 exactly equal my 3 plus 4. So that is exactly equal 3 plus 4. And the base is my 2. Okay, So now from here, this calculation at the beginning to the result at the end, we can got this formula: a to the power of m times a to the power of n and equal a to the power m plus n. And now we check the division. So the first one we finish. Now we check this one, second one. Division. When you divide two powers, and you can find they will use the indices, do a subtraction. Okay, so that is the first one. That is our second law. So from this one, we can give your example like this. So I have 2 to the power of 4 and of 5, and divide by 2 to the power of 3. So on the top, that means 5 lots of 2 times each other. And check the denominator, that is 3 lots of 2 times each other. And then we can do the cancel. Cancel a pair of 2 from top and bottom. So I keep the value will be same fraction or equivalent fraction. So the second pair I can cancel, the third pair I can cancel, and now I got 2 times by 2. So that is equal to 2 to the power of 2. And this 2 you can find out that exactly equal 5 take 3 equal to this power 2. Okay, so now that means from this law here, you can find this law also. It makes sense. So top is m and bottom is n, and then the result is m take n. So that is your 2 to the power 2 come from. Okay, now we check the law 3. So law 2, law 1, and law 2, they always have the same base. They do multiplication, they do division, and then you have the power or indices, the plus or take. And now we're talking about power to power. So this one name, we call them power to a power. So it's like inside will be a power, outside also a power. So now we have a look. So that is number 3. So a to the power of m, outside is n, is equal a to the power mn. Mn here, without the symbol, always means times. That is algebra law told us, okay? So now we check this one, and we give you example to see if it's work or not. So 2 to the power of 3, and the top is 4, okay? So now what's that equal to? That means your base times by itself 4 times. And now we can see here, so here they have 3 lots of 2, here 3 lots of 2. So keep on, they all time each other. So totally I have 12 lots of 2 time each other. So that is equal to 12. And now you check this 12 exactly equals 3 times by 4. Okay? So the mn exactly equal m times n. So this law will also can prove that from this calculation. So 3, 4, that is 12. Okay? So now we'll check the number 4s. Number 4s is talking about power of a product. So this one, you can remember this one is power of product, and also remember next one is power of a quotient. So one is multiplication inside bracket, one is division inside bracket. So now we have a look some examples. Okay, I will copy this one down to here. So that is number 4. So AB to the power of m is equal A to the power of m, B to the power of m. Number 5 is A divided by B, and that is the power to all the efforts. Okay, sorry about this, guys. So now we have a look this one. So AB to the power of m, then we can get that is so 2 times by 3 to the power of 4. So that means I have 2 times by 3 once, then 2 times by 3 second times, then third time, and then the fourth time. Okay, then I have, that is my first base, second, third, fourth, and they time each other. And then I can find, I have 4 lots of 2 time each other. And I have 4 lots of 3 time each other. And then I got 2 to the power 4 times 3 to the power 4. So that's already proved. This one is AB to the power of m is equal A to the power of m times B to the power of m. Okay, now we check the division. Division is the same thing. So now I use 2 over 3 to the power of 4. So now we got 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3. And we know from the multiplication, I can times the top by itself, denominator by itself. And then I write down as the indices. So that's powerful, and that is powerful. Okay, so now we can find it. This law, we can also use this kind of numbers to do the provement. So it's work. So now we check the law 6. Law 6 is the 0, 1. 0 equal to 1. Some of my students always confused with that one. So now I'm happy to explain that, guys. So guys, now we have a look. So if I use base A, okay, so base A, oh, before that, I probably use a number. So like 2 to the power of 3 divided by 2 to the power of 3. So from the division, so what's the power is that? I should use 3, take 3, yeah? If you're not sure about this, I change this power. So 2 to the power 3 over 2 to the power 2. So that means the top is 3 lots of 2 times each other. Bottom is 2 lots of 2. Then you cancel a pair of them. So I got 2 to the power of 1. In the same situation, 2 to the power 3 over 2 to the power 3. So that means you have 3 lots of 2 on the top, 3 lots of 2 at denominator, and you cancel that, you will get 1. But before we got to the 1, you also have to remember 2 to the power 3. I can use division law here, the second law. So I can use a to the power of m over a to the power n. They equal a to the power m take n. So this one I can write down is 2 to the power 3 take 3. So 3 take 3, we know that is 0. So 2 to the power of 0 equal to 1. And the same way, we can do a to the power of 2 over a to the power of 2. So it's a to the power 2 take 2. So a to the power of 0, that is equal to 1. Because a squared divided by itself, a squared will be equal to 1. So now we have this provement. So a to the power 0 equal to 1. Okay, now we check the number 7. Number 7 is if we have negative indices, and can we write down like this? Okay, so now we use 7. So I use a to the power of 2 divided by a to the power 3 this time. So from the index law, I should use 2 take 3. So that is a to the power negative 1. And now we check the left-hand side. So this whole thing I can rewrite as top is 2 lots of a times each other, bottom is 3 lots of a times each other. So I can cancel this pair of a. So that will be got 1 over a. So 1 over a exactly equal this side. And then the other side, I can got a to the power negative 1. So that it means 1 over a equal a to the power negative 1. So that is law 7. And guys, so this one is a to the power negative 1. So how about a to the power negative 2? Think about that. So that means you should have the a to the power of 2, and then that's equal. Why? Okay, we check. So if I have a squared divided by a to the power of 4, and then that is 2 lots of a, that is 4 lots of a. Cancel a pair of that. This exactly equal. So a 1 over a squared. And that is also equal a to the power 2 take 4. So negative 2. So they are equal. Now check, if I give you cube, so what you can write? -3. If I give you 4, so what you can write? -4. That is the reason, okay? So you can write down a common formula is 1 to the a to the power of m. So that is -m, okay? So that means if I give you a to the power -1, you can write down what? A to the power -1. So a to the power of 1, that is a, okay? So keep that in your mind, and when we do the questions later, we can use all these laws. So now we have a look. We already do the revision for all the laws, and then you can have a look some kind of question. I think all these examples supposed to be not a very hard question, and you can calculate by yourself. So I probably will pick 2 or 3 questions to explain. For example, like 1b. So 1b, I have 3 times 4. I got is coefficient, so that is 12. And then a squared times a, so a squared times a, so that is 3 lots away. So I can write down a to the power of cube. Then I can check how many b here. So I have b and then b cube. So it time each other. So they have b to the power 1 plus 3. So here nothing is means 1. 1 plus 3. So that is 4. So this one is your result. And do the division. I always told my class is when you do division, try to write down as algebra fraction, because that will be easy for us to recognize what I should simplify. So 4 and 8, that is 1 and 2. And x2 and x is 1. So I got that is x on the top. y5 and y2, so they are y equal 5, take 2, so that is cube. Okay, just to change that to a format which looks very comfortable. Okay, so that is xy cube over 2. So question D. Now we check question C. Question C is we use the power to power. So check the top, it's a to the power 2, and outside is power 3, so a to the power of 6. 2 times by 3 equals 6. And the bottom is 2 and b to the power of 3. Guys, check. Is this answer correct? This one is definitely wrong. Okay? If you write down this answer, I give you 0 mark. So what you have to pay attention is the top, I do that power to power. And the bottom here, the denominator also need to power to power. And power to power is 2 times 3, 6. On bottom here is 2 cube times b cube. So you have to write down the answer is 8b cube. That is good answer. Okay. So now we have a look at example 3. This kind of question you always keep in your mind. So that is equal to 1. I used to ask my class like 300 x to the power of 5, y to the power of 3, z to the power of half, then log. So that is 2 and then 32. And also times square root, so 123 with the power 0 equal 1. So guys, you don't need care. So what is the base? Just make sure the base is not equal to 0. Okay, then a to the power of 1, a not equal to 0, a not equal to 0, and a to the power of 1 will be a to the power 0 always equal to 1. So keep that in your mind. You don't need very focus what the base value is. If the power is 0, just 1. Okay. So now this one is 4 times 1. So that is 4. So because 4 a to the power 0, they time each other. Only time symbol you can omit or leave out. So now we check question B. B is 2 times p to the power 0, 1, plus this whole thing is 1. So 2 plus 1, that is 3. Okay, now we have a look at the last one. The last one is very common question, okay? They will always check with you. So with this one, you can write as a division, so like a fraction directly. or you do step by step. So I just copy down and then do as a fraction. So now we'll check. So 3 and 6. So 2 and 6 I can simplify. 2 and 6 I can simplify. So I can got is 3 here. Okay, and then y square I can simplify with this cube. So I only have y to the power of 1. And now I can write down the solution. So 3 times 3 will be equal to 9. X squared times x to the power of 1, so x cubed. So this means it's x to the power of 1. And y to the power of 1, green 1, plus 4, so that is 5. So that is your final answer. Now we check question B. B is 3 times by 4, so that is equal to 12. But before you times each other, you can also cancel this. So that is 2, that is 1. Then I just keep on cancel. So I will figure out what is in this bracket. Okay, after I break the bracket, what I'm going to have. So I got 3, then times x cubed. So power, and also y to the power 2 times 3, so that's 6. And then times this 4 already gone, it's go to 1 now. And then times x to the power 4 y squared. And the bottom is go to 2 now, x squared and y. Okay, so now we just check. So this 2 we can't do any simplify, but with y cube I can do this simplify here. So that is I only have 1x left behind. I have only 1x left behind. Okay, so this one is I have x squared cancel. I only have 1x left behind. And then y to the power of 6, I can also cancel. So this one, I got y to the power 6 is y. I have y to the power of 5. So now I can write down my solution. So the top, I have 3, because the 1 means times by 3 is still 3. And 2 as bottom. And then x cubed, I only got 1x left. Cancel with x squared. And y to the power of 6, I cancel with this y. So y to the power of 5. And then I times by x to the power of 4, y squared. Then I just got to the final answer is x to the power, this is 1 here, 5, y to the power 7. So that is the answer for this kind of question. So also guys, if I got any mistake, please let me know. Okay, normally I won't got mistake, but just in case, because yeah, I always told my students I'm a human. So human will be, yeah, got mistake. I'm not a calculator. You can't assume me I got all the questions correct. But basically, I've got most of the questions correct. Okay, guys, so today is what we did is we do the revision for the index law in our year 9. And this is one chapter in your year 9. So it took about 3 lessons, I think, 3 or 4 lessons in Hazy, and we study the index laws. So I use only one lesson to go through all the laws, and hopefully, yeah, you can keep all these laws in your mind. And then when we do this kind of question, and you can figure out the answer. Okay, so they also have some calculation and my solution here. You can have a look, and also this one. Okay, you can have a look. Okay, so everyone, so today we finish here, and good luck for your math study. See you next time.